Hello, everybody. It is 12:42 p.m. Central Time on the 12th of December, 2020. It's Saturday here in the United States. Hope you're doing well. About as well can be, I suppose. We're here to talk about seismic events again, and we're using Earthquake 3D, the program. We're using the paid version, which allows you to combine feeds, and we're using the USGS along with the EMSC coming out of Europe. Give us a good idea of what struck around the planet. Additionally, we're looking at about 48 hours worth of earthquakes. The younger earthquakes are marked in white, and the older earthquakes a day ago, 2 days ago, marked in a pinkish color. Finally, for the new people, the earthquakes which are raised high off the globe are deep down into the earth. And the deeper they are, we watch these for shallower, larger earthquakes to take place, spreading out and away from where the deep earthquakes begin. Okay, so I'm going to turn on a display capture here, and I quickly just need to get something out of the way for my Australian viewers. You don't see it on the feed here anymore. The Europeans reported it. I don't have Geoscience Australia turned on the feed, but you guys can go check. Kangaroo Island got hit this morning, or last night, your time. 2.6 earthquake, so mid-range 2 coming in right next to Adelaide at Kangaroo Island. That follows the other earthquake that came in up to the northwest, prompting me to issue those warnings last week for Perth, for the center part of the plate over by Uluru or Ayers Rock, and down at Kangaroo Island. And now Kangaroo Island's the final one to get hit, so check it off the list. Go over and check Geoscience Australia if you want to see the actual earthquake. So deep earthquakes happened yesterday, and then spreading out and away from the deep earthquakes, a series of 4s and 5s, filling in each other's middle points, the middle points between our current sets of quakes. We have a 5.0 in eastern Papua New Guinea at the Solomon Islands, 4.6 going back down next to the island of New Caledonia here, and then going down towards New Zealand. North tip of New Zealand, right in the middle of the Bay of Plenty, a moderately deep earthquake. Something that we need to keep an eye on, again, whenever we see any kind of activity in the Bay of Plenty. You have to watch near White Island. There's a volcano right in the middle of that bay there. It looks like a catcher's mitt. Right in the middle of the catcher's mitt, or right down here, we have the volcano. So something's going on in New Zealand. There's been a series of earthquakes down to the south, going all the way down to our letter X, back across central New Zealand, up to North New Zealand, with the North Island getting hit this past week. It's a little bit of shifting after all the deep earthquake activity. As we go further over to the west, a series of 5s going across over into Indonesia, where this 5 is sandwiched between the other 2 previous earthquakes, 4.6 and 4.9. My phone's ringing. Hold on. Sorry, guys. Waiting for a call from the Duchess. Oh, man. That's not her. It's my buddy calling. I didn't even answer. He went to voicemail. All right. He'll probably call back. Anyway, let's carry on. Okay, a professional update here. So we have a series of 5s going across Indonesia, where the 5 here is in the middle point between our 4.9 and our 4.6. If we take the 4.9 plus the 4.6, we're at 5.06, or you could round it up to a 5.1. Why does that matter? Because a 5.2 struck right in the middle. A slightly larger earthquake at the middle point between our other 2 earthquakes. Going up to the north, we have a 5.5, which struck on the coast of Honshu, Japan, north of Tokyo. That's a significant sized quake for the area. It's not exactly huge, it's not big, it's just significant. It's enough to get your attention, but not a massive quake. Although that is the location right south of there, where the 9.0 mega quake struck with the big tsunami 10 years ago. Or almost 10 years ago, back in March of 2011. We're getting to the 10-year anniversary. Okay, so that all happened since yesterday. And then we go over into China, and we're right at the border of Myanmar and China. Now, I mean, we're right at the border. But nothing around the plate boundary to the east of it. So no big earthquakes reported out of China this past week. We are now past the 10-day watch. All that weirdness came in with all those weird reports coming out of China, but I can't verify any of that. 4.7 yesterday, Lake Baikal, deepest freshwater lake in the world, and then over to the west, or is it the biggest? No, it's the deepest? I don't know. Okay. 4.7 over north of the Taklamakan Desert in China, so it's two 4.7s. This one from a day ago, and this one today. Going over to the west, another 4.7 struck. And this struck on the plate boundary down at those laccoliths, which I showed you in previous updates in South Iran on the plate boundary. Let's just take you over and show you roughly where it struck. Right down in here. Oh, wait, let's turn off our borders and labels. Places and roads. There we are. So now you should be able to see all of these bulging laccoliths coming up out of the plate. Some of them have ruptured, actually, in the past. Here, for instance. Okay. So on the USGS map, let's bring that up now, the plate boundary map. The red line over here going through Iran. That's where the other 4.7 struck. So what's in between them? Look at this. From yesterday, a 4.2 at the tip of the arrow. So it's really a stepping stone path of 4.7s with one 4.2 from yesterday in between. Do you see that? Here, let me back that out so you can see the spacing on that. The spacing on this is significant because I think what's going on here is a standing wave, where the wave peaks or the wave valleys or troughs, the bottoms of the wave or the top, is where the earthquake is taking place as the standing wave is spreading out through the tank. And, well, in this case, it's not a tank in a laboratory, like what you see on the screen here now. Instead, it's going across the plate, following the edges of the cratons, dropping off 4.7. Imagine each one of these is a 4.7 earthquake. And then it moves and drops off another 4.7 earthquake at the middle point between the previous wave as it was moving. And that's what we have here. In a day's time, across from the, again, Siberia, across China, down across Afghanistan, going down all the way into Iran. Now let's go back over to the plate boundary map because USGS has nothing across here, right? But yet we have a stepping stone path of the same sized earthquakes going across this area. Now let's go my map here and you'll see we have an arrow right across there. Two arrows coming in from up to the north where our deep earthquakes leverage in on the underside of the plate. So how much energy do you think it would take to displace all of Russia, Siberia that is, all of Siberia, pretty much all of North China, the Middle East, all the way to Iran in a day's time? This is the arrival of the energy coming up through the plates from our solar event that happened back on the 10th. It's now 2 days after. We're going to start seeing it. And, oh, by the way, the number of deep earthquakes has increased in the past 2 days again. It's starting to go up. We're starting to see new deep earthquakes hammer in where our letter Ds are. The letter Ds are spots where we watch for new deep earthquakes to take place, and it's happening again right now. So, for instance, 3 here since yesterday, and 3 here since yesterday. That's at least 6. So, recapping, a stepping stone path of the same-sized earthquakes going across over into Iran, and then over here across the Black Sea. This is that body of water here, Black Sea, north of Turkey, 4.3. Also, Poland moving, as well as the Italy-France border region moving, as well as our arrow tip down at Gibraltar and our arrow tip out at the Azores. Now, all these earthquakes are about the same size. We're going up into the mid-range 3 level. Once we get up to North Europe, we go down to 2s. So, in other words, we go 4s, 3s, 2s, and then we reaccumulate back to a nearer 4, 3.7, 3.1, 3.0, 2.9. Add them all together, it equals about a 4. Out at the tail end, where the X is, let me get the X on the map here, where the arrow points to the letter X, X marks the spot at the Azores. The reason we have that there, it's the dead end for the plate boundary. So this power is transferring across Europe. It goes out following the plate boundary to the letter X there, and it's trying to go around the outside edge of Europe following the craton edge, where we have our arrow here, over in Eastern Europe. You got to remember, a day and a half, 2 days ago, Romania got hit with a 3. So 3 in Romania, now at upper 2, mid-range 2, along the edge of the arrow, which is the edge of the craton in Europe. Let's jump back across and go over to Central America and South America. South America is pretty easy to sum up right now. A series of 4s, all clustered in where our previous activity was really hammering away up to a 6. Now it's all 4s. I think this is going to take a huge step up in the next few days. And we could go up by 2 full magnitudes, which is a 100-fold increase in power. We could go back up to the mid-range 6 level. I'll explain where in a second, but first, let's explain what happened in the past day and a half to 2 days. Energy went down to the South Sandwich Islands. So it escaped out. Energy escaped out, went down to the letter X again. X marks the spot. Hit spot on, right at the tip of the South Sandwich Islands. And let me explain on the USGS map what happened here. Energy or tension transferred across the Pacific up to the north, following the fracture zones to the north, Central America, Northern South America, and energy transferred down to the south, going into South Central Chile, and then the middle point between the two came under stress, and all that broke in the past few days. Let's just say the last 5 to 6 days, that all happened. Then energy transferred down here. Following the arrows, the trajectory, I can't even say it, trajectory, which struck in the past few days, was fulfilled. So in other words, the flow went across from one point to the other. Little tongue twister there. This is live. We'll do the Bill O'Reilly, only I'm not going to say the F-bomb. Okay, here we are. Central America going into South America. The increase also took place up here to the north. So we had volcanic activity increase at Nevado del Ruiz volcano here in Colombia, as well as down here to the south at Ecuador, we had Sanjay and Reventador both erupting. Sabancaya, which is a regular eruptor, down here to the south as well, down in South Peru. Nevado de Chilean also started to erupt down in Chile. So let's add those up. 1, 2, 3, 4, 5 volcanoes erupting across South America in the past week. Across Central America, we have Telica volcano, or Telica, going up to Fuego. That's right in here. Fuego's at Guatemala. And Popocatépetl. So let's just go quickly look at the Volcanic Ash Advisory Center, and I'll show you where those are. Sabancaya, already mentioned. Fuego, already mentioned. Dukono, I did not mention, but that's over in Indonesia. Kluchevskoy keeps going with 20,000-foot-high blast, but that's somewhat normal for the volcano. Popocatépetl in Mexico again. Epico volcano, which went up to 10,000 feet. That's up in the Kamchatka Peninsula. Ibu back down in Indonesia. Oh, wait, hold on. Santia Guido. No, it's Santa Guido. They have it misspelled there. Okay, so Santa Guido is erupting. And it's not exactly huge. Let's see. Do they even have a flight level on this? No volcanic ash observed, but they, I guess, seismically observed an eruption? Okay, so there was some kind of small seismic event there. Santa Guido. All right. Well, this makes a difference. It really does. So let's go back up here into Central America. The new addition, Santa Guido, right here in Guatemala, where we already have Fuego erupting. So now that's 2 in Guatemala, adding in Telica volcano here in Nicaragua, and then down here, Nevado del Ruiz volcano erupting in Colombia. 1, 2, 3, 4, 5 across Central America, including Popocatépetl. So that's 5 across Central America, 5 across South America. That's 10 across the East Pacific in the last day and a half to 2 days. 10 volcanoes going. That should be letting us know something's coming seismically shortly thereafter. Each volcanic eruption, I've told people in the past, equals about a 5.0 earthquake. So to see just a few clusters of 4s means something much bigger is going to be coming in. Like I said, a 10 to a 100-fold increase in power. We're talking about going from 4s up into mid-range 6s. Now the spots that should get hit, just like everywhere else on the planet, should be between our current sets of earthquakes. So for instance, right down here, right between all of our sets of earthquakes in Chile, North Chile, going into the Argentina-Bolivia border region, all the rings overlap there. The halfway point between our sets of earthquakes. Now there's another halfway point between our sets of earthquakes. That's in Peru. That's central North Peru, right on our arrow. Another halfway point between our sets of quakes is where all the rings overlap here. That would be one, let's see, in the past 48 hours, let's make sure this is 48 hours. One spot in South Mexico, right at the Guatemala border, where the 2 volcanoes are going in. Actually, it's 3 volcanoes. Popocatépetl on one side, Santa Guido and Fuego on the other. South Mexico, where the rings overlap between the pinkish-colored earthquake and the white-colored earthquake. That's the first spot. Second spot is right here at Nicaragua, where the other volcano is erupting, ironically. That's where the rings overlap there. And the third spot we would watch is here at Colombia. All three should get hit, where the sets of rings overlap. And it should be something larger than what's currently there now, and we have to take the volcanoes into account. Like I said, each volcanic eruption equals about a 5.0 earthquake. So we're about ready to go back up into the 6th level. Over to the east, over in the Eastern Caribbean, let's just take a quick look over here. Venezuela started to move last night with a 4.5, right at the middle point between where our two plate boundaries are not marked on the USGS map. And so that middle point, that fulcrum point between the two plate boundary edges, came under stress. Now, I have a warning going for eastern Venezuela going as far north up into the Eastern Caribbean, and today is pretty much the last day of the warning. We'll watch until tomorrow for that mid-range to upper 5 to come rolling in. It already is down across to the south. Now, you see the USGS has nothing there between Colombia and Venezuela. But let's go in and show you what I have here. Look where the earthquake struck. Hold on. These arrows have been on here for years, so nobody can say it's just been added or anything. It's right on the arrow on the edge of the Andes Mountains that comes up and makes a bend up to the north and goes over to the east on the Craton edge, if you will, which the USGS, going back to their map, just blank. But the mountain range makes the bend right across between the two. Come on, it's connection. And the earthquake's right in the middle, right on the arrow, right where the mountain range is. That's the 4.5. Something's coming across right now. And think of this like a train coming across a bridge. At the end of the bridge, we got a wall. It's going to be impacting into the wall in the next few days. And a 4.5 is coming across the plate. It's not coming across some massive area either, so it's not going to lose that much energy going over to the east. Now, getting into the United States, let's go up here, all the way up into Alaska. So, Alaskans, guys, it moved really heavy when the solar storm arrived and buffeted Earth, but I'm not surprised. That's up north in the Arctic, up north of the 49th. And the solar storm that came in, of course, affects the poles with the northern lights. Series of 4s broke out across the plate boundary. Let's show it to you on the plate boundary map. A series of 4s broke out across this. Now hold up, because back over here, 2 volcanoes are erupting. That's Kluchevskoye volcano with 20,000 foot high blasts here on Kamchatka, and Ebeko volcano on the small island just south of the tip of the peninsula. So 2 volcanoes are erupting here. Then look at our seismic. 5.5 back behind it over in Japan. So really, 5.5 there in Japan, and then at the middle point between our earthquakes over in Alaska and the earthquakes at Japan, 2 volcanoes erupting here. Again, Kluchevskoye and Ebeko, right in the middle where the fold and the bend of the plate boundary is. Let me back this out so you can see it. Right here. 2 volcanoes are erupting in between our sets of seismic. That's not a coincidence. It's the fulcrum point. So 5's here, 4's going up into Alaska once we go into Alaska proper. It goes from 4's down to 3's. But the 3's, well, and 2's, 3's and 2's, go all the way across in like a line, like a ramp. This is where we jump off the plate boundary and we go up into Alaska, focusing in on Mount Denali and everything south thereof, putting it down into Anchorage. All of the whole basin around Anchorage is moving. Now, whenever I see this happen, whenever I see the area around Anchorage move, right down into Anchorage, but you see it. It goes up to Mount Denali and it kind of goes all the way back around with Anchorage at the center. That's when I watch Alaska up here for something to happen where all the earthquakes are moving around it. It's pretty basic. It's also on the edge of the Craton, the accretionary belt going out to the coastal plain. So it's a weak point that collects energy that comes across from the Pacific, and we know it's spreading out right now. It's going across from the Pacific over into Russia. Remember the equal spaced earthquakes that I showed you at the start of this update. It's spreading across Asia this way, so it stands to reason it should also go this way, and technically it is. It's 4-point-somethings for mid-range 4s going up into the plate. Now we get down here into Canada, and unless it's a significant sized earthquake, the USGS does not bother to report it. And if you go try to check the NR Canada feed on Earthquake 3D, it no longer works, whatever they changed on their website. And it's still a 30-day feed on their website, that's a static website page that just lists all the earthquakes for the last 30 days. Pretty interesting that the NR Canada site also goes into sleep mode on the weekends when they leave the offices and leave it automated. From what I understand, they take the weekends off. At least that's what I heard. So, unless it's big, there's nothing to report. Down to the south, a 5 came rolling in at the California-Nevada border, woke everybody up. Unfortunately, it did not wake me up. This struck in the middle of the night for me, but Mina, Nevada, one more time, a 6.4 kilometer depth, and out in the middle of the desert, it was felt by at least 80 people who managed to get onto the USGS site. So it's way more people than that felt it. It's just 80 people managed to actually get onto the site late night and report this. I'd like to go put the coordinates in really quick and just see where we are in relation to the others. There was a 6.5 earthquake, a series of other 5s that broke out at the California-Nevada border, right to the south of here. Let me turn on the borders and labels just so you can see where the California border is. This gray line here is the California border. On the California side, we have a supervolcano, Long Valley Caldera. Now on the east side, where the coordinates are, we're coming in next to an old quarry. These are old. It looks like it hasn't been used in a while. The sides are collapsed completely, and it doesn't look like there's a way to get down in there anymore. Unless you have some mountain climbing gear. You're not going to be driving many trucks down that, at least from what I can see. Maybe you can around the outside edge, but you can see it's old. So that's what's at the location, but the earthquakes are happening down in the crust. It's not like they're happening right up at the surface. These are happening 6 kilometers down in the crust. So there's something else there, though. There's a volcano that's on the side of this. These are lava flows and black basalt flows. Over to the east, we have Coaldale Volcanic Butte. And the 6.5 earthquake and huge swarm that struck 6 to 7 months ago, and a surface fissure fracture, or crack in the ground, that formed 12 miles long, going pretty much this direction, heading this direction over towards where the quarries are. So it could be that the quarries have aided in the crack spreading across the area, or that it's getting ready to happen. Regardless, it's a 5 at an old volcano at a quarry right at the back tip of our arrow. Let's wait for it again. There. Now you see it says 4.9. I'd like to just go look it up. Go look up the stations, see what they show. This is going to show us the station list from the USGS, and I just want to see how many different earthquakes are reported from the different stations, how big they went. Now the way we do this is we throw out the high end, and we throw out the low end, and that gives us a better idea of what actually struck. So let's see, we're going as high as a 5.3, 5.1, 5.2, 5.3. Okay, we throw out the 5.2 and 5.3. Maybe even the 5.1, 5.2, and 5.3. But we also throw out the 4.6, 4.7, and 4.8. So what does that leave us with? 4.9 to 5 to 5.1. That's what hit. And what did the USGS decide to go with? 4.9. Go figure. We have a little joke about the 4.9s with the USGS. But anyway, the 4.9 came in at a weak point, and it came in right after California started to go into overdrive with the number of earthquakes spreading down across the California-Nevada border and so forth, going down into Southern California. The last 2 days, look at the spread of earthquakes here. Let me turn it down to 0.0 and greater so you can just get a good idea of how much area moved, how big of an area actually shifted on this. So all of these indicate small earthquake locations. Think of these like vibrations as the plate starts to shift. Now, I can compare this to the spot down to the east-southeast, and let me show you. Here. On the USGS map, the plate boundary, this thick red line, and all the thin red lines. Now, you notice the thick red line and all the thin red lines, at least along the coast and going over to the California-Nevada border, are all pretty much going the same direction until we get down to the Garlock Fault here, which goes east to west. But then from there, we pick back up and go northwest to southeast again across the Mojave. They're all going in the same direction back up to here, where they meet into the Juan de Fuca fracture zone. The famous Juan de Fuca out here in the Cascadia subduction zone, supposedly. Well, all the earthquakes spread out from the Cascadia subduction zone, and we spread out following all the thick red lines in a diagonal line northwest to southeast. And the thin red lines that I showed you but they're all going same direction, where the swarms are happening at these weak points in the plate. For instance, I just showed you the supervolcano over to the east, going over to Monte Cristo Hills, and everything in between. Volcanic. All of it in between. I can look up each location. I just showed you the supervolcano here on the California side of the border. Mono Lake's right at the border, and we jump over across the border to the quarry and the old volcanic flow, and then over to Monte Cristo Hills Volcanic Center with the arrow on it. Goes right over to the arrow. So all of these, and again, you can look up each one to verify. I've showed them in every update. Volcanoes. Now there's other things nearby these locations over on the west coast, northwest for instance. As we go up to the north into Lake Tahoe, notice how most of the earthquakes are starting north of Lake Tahoe. They go over to the area west of Lake Tahoe, over into the central point of the valley, and then make a ring shape almost back across over into Pyramid Lake. All of this right here, where most of the earthquakes are happening around this. Well, I've showed this spot many times between Lake Tahoe and Pyramid Lake. It's my contention that this is the remnant of an ancient caldera that is yet undiscovered by professionals. This giant oval shape that is lined with volcanoes around the outside edge. It gets hit with earthquakes around the outside edge, going into the middle of it. On both sides, we have two deep basins which have folded and formed. That's Lake Tahoe and Pyramid Lake on either side, north and south. And on either side, north and south, virtually equally spaced, geothermal fumarole fields and geyser fields. So this is the Needles. These are the Needles fumarole field. And down to the south, we have a geothermal field at Steamboat Springs, where they've drilled in to get steam. So, two geothermal fields, two folds or basins on either side, an oval shape, lined with volcanoes, gets hit with earthquakes, and it got hit with fires and hot spots around the same shape over the past few years. After the earthquake swarms come in, no less, and right now, we have a little outbreak going on all the way around the oval shape. Now we can go to the north side slightly with a 1.2 and a 2.1, and we go to the south side ever so slightly with a 1.5 and a 1. But I would say these equally spaced clusters on either side of the oval would be a sign of the greater area shifting around what could be, in my estimation, this is a supervolcano. Just like this supervolcano down to the south is confirmed a supervolcano at Long Valley with 1,000 cubic kilometers of melt down below. But if you look at it overall, the earthquakes are going around the whole thing, not just the caldera. So let's just show you. Down here to the south, it's doing the same thing. That this makes a ring around the greater area of the supervolcano and all the volcanic locations around it, just like this is up to the north, doing the same thing. But the areas are huge. Now let's go back to the USGS plate boundary map, because the two supervolcanoes, well, at least one that's confirmed here, where all the faults are, look where the other one is up to the north. Same thing. A bunch of faults marked around it, like a cluster. Now these are well mapped down to the south. They haven't mapped this up to the north. I think when they do, they're going to find out that it is. I think we'll find at some point that I'm correct on that. That's an ancient caldera from a supervolcano along the North California-Nevada border. Nonetheless, a series of earthquakes striking across both. Going back up to the north, we have a lone earthquake up here at the northeast side of California. Likely California. Oh man, what a name. Likely California. Let's put the coordinates in and go see. Right next to Briscoe Butte volcano and north of Twin Butte South and Observation Peak. Now, these are marked volcanoes here, but all of these going back down, here, let me zoom in and should prove this to you, have a collapsed crater with rising, bulging dome out of the center. This is a volcano. It's just not marked. It's not a current volcano. It's not currently rising, but it has an old dome in the center, just like all of them. And they have the shape. It's just for some reason I don't have the place marked. So they probably are named too, but I just don't have the downloads for it. We're at Eagle Lake Volcanic Field. What do we have going on across here? An old Pleistocene volcano. Volcanic Field occupies the junction of the Cascade, Sierra Nevada, Basin and Range geologic provinces. 15 cinder cones and basaltic lava flows. 15. Yeah, I bet that is. I bet if you count these out, it'll probably be 15 of them, right? That's what this is. Okay. Yeah, again, I mean, you don't have to take my word for it. You can go look them up. The earthquake is coming in on the north side, right next to Briscoe Butte. Let's go see what Briscoe Butte looks like. To even call this a volcano is not doing it justice. Let's say it used to be a volcano a long time ago, back when this was all underwater, maybe. That it has tuftage on top and an old flow, maybe, but that flow looks like it formed underwater a long time ago. Wait, how long ago was this all underwater? Back when Salt Lake used to spread out all over to here. Okay, let's just say time of the dinosaurs. However long that ago was, right? Oh, wait, hold on. We've got ourselves a hotspot up here. Hold on, we've got a hotspot. A brand new hotspot. What's the temperature on this? Multiple hotspots in one spot. 64,000 again. The false reading, is it coming in next to a power line or something? Wouldn't that be weird? Let's go see. I see a road through here. I don't see anything of any significance. An old, maybe quarry of some kind there from a long time ago. That's an oddity. What else do we have? I mean, this right here kind of speaks for itself, but it doesn't have a name on it. It's going through here. It's a road going right through the middle of it. But that shape, just to me, says that possible ancient volcanism not marked. Oh, wait, look what we're right next to. A set of power lines, huge power lines again. Is that what these are? Oh, yeah, there are. Not just one set, 3 sets. 3 sets of power lines there. Yep, they curl and curve down to the south, where the other hotspots were from previous. When are these hotspots from? December 11th, yesterday. So yesterday this was hotspotting out as well. And look, the power lines make a bend and go right through there. What are these? Interesting. Wow, the only hotspot to be reported, it's right next to a set of high voltage power lines. Okay, well that's pretty interesting. Let's go up to the California-Oregon border and go see what's up at Hornbrook, California. I'm not going to be looking all these earthquakes up, guys. It would take the rest of the day. There's so many of them. I'm going to try and weave this together into something that makes a little sense. So look where we are again. We're on the edge of an ancient volcanic field from the Pleistocene. Lava flows from 2 cinder cones at Copco Lake. And let's just see what they look like. Yeah, okay. Yeah, I mean, this is, again, look at the tiny crater on there. You could camp out inside of there. That's crazy. Okay. Is there anything else here? I just want to look in and see. Earthquake's coming in. Wait, hold on. Whoop, whoop. Bop, bop, bop. Got ourselves another set of high voltage power lines right here. Next to where the earthquake is now. Not a hotspot. We have an earthquake there. Where are the high voltage power lines going back to? Well, they're going back to that little town. They're carrying on past here. Do they got some kind of power generation here? Yes, they sure do. They got themselves a hydroelectric dam at that location, at Copco Buttes. So they built the dam on the side of a volcano, and they've got the hydroelectric dam there. Then spreading out from there, the power lines go right across here, and we got a new earthquake right next to the hydroelectric dam and the power lines. Now, keep in mind, over here to the east, we've got ourselves an earthquake next to a volcano, ancient volcanic field, and we have hotspots developing out next to power lines. Let's go across the border over into Oregon. Klamath Falls. Klamath Falls, Oregon. Klamath Falls, Oregon. Whatever. Whatever way you say it. Hey, look, we're right next to another set of high voltage power lines. These are huge, and it's not just one set. There's 1, 2, 3, 4, 5 different sets of lines there on different towers. And these are the big kind, the big mega towers, next to smaller, large towers. They're not the kind that go to your house. Yep. I don't see any others on any way to all the way down to the south. We have to go over to the next county to get them. The chances of coming in next to these power lines all the time is just too weird. And here's the hotspot, by the way. Oh, wait, does this go over to the east to that hotspot? It sure does. Those power lines go over to the east as well. That's where the hotspot is. Earthquake hotspot, same county. Power line, same county. The rest of Oregon doesn't have anything reported. Are you serious? Let's go up into Washington. Go see what's right there at the border with Washington. Mother Nature stopping at the borders. Giving Oregon a break. Must be nice. Always get a break of earthquakes. Never have anything hit. Out of sight, out of mind. Let's go look it up, see what's there. Oregon border. Oh, Washington side of the border. What's the nearest town? It's listed as Ellsworth Springs. Okay, is there anything else of significance nearby? Let's just zoom in. A little park. What is this? Is that a house? Is that a house? Oh my God, look at that. It's got like 5 turrets and... Is that the local lord live in town there? I say it, I'm Lord so-and-so, king of... Wait, we're right across from a giant airport. Okay. Right across from the airport. Now, there could be something else nearby, but I don't have any of that marked. Let's go up to the north. Go take a look. 1.0. Oh, an explosion? We got an explosion now. Now you're starting to explode in Washington all of a sudden. We were exploding in Oregon. Now we're exploding in Washington? What? We got an explosion. I don't know. It is a small quarry. There is finally a small quarry at one of these locations. You know, we get a lot of these explosions out here. There's no quarry. But quarrying on the side of Mount St. Helens, I don't know. An explosion at a quarry on the side of Mount St. Helens. Let's call it that, because that's what it is. Now wait, hold up. A 0.5 over to the east, Royal City, Washington, again? When is that from? The 10th? 2 days ago? Okay, we got to get that out of there. Let's go turn on the last 24-hour feed at this point. That'll reduce the number of earthquakes here, make it a little easier to look these things up. Okay, 24 hours. In the last day, we just got 1. That's a difference, wouldn't you say? To go from yesterday, which I didn't look those up, so that's why I'm looking them up now, but that today's earthquakes is just nothing. Hush, hush. Quiet. And that's not good. We do not want to see total quiet up here. Okay, that reduces it, so I don't need to look up Royal City. That's in my last update from 2 days ago. Let's go see where this 0.5 is. Is that an explosion of some kind? That's not an explosion. It's at an 18-kilometer depth. Here's the earthquake epicenter. So 18 kilometers down below that creek bed on the side of Mount Rainier. North side of Mount Rainier on the Seattle Fault. That's where the little earthquake is. So what happened? It went from overdrive down to nothing within a day. So I'd like to actually go look at the tremors. Go see what's going on with the tremor map. Let's do that. Let's pull up the tremors. There we are. So we're back to 100 tremors, and we're in Northern California with these. Now, they do have magnitudes assigned to them, but they're vibrations as the plate shifts. Think of these more like vibrations as opposed to breaks. So instead of a fault breaking, the whole plate is shifting. And look where it's shifting. Northern California. Northern California. Let's go back one day to the 10th and see what it was doing. 82. But it's not Northern California, is it? It's Southwest Oregon. The Washington-Oregon border and the Puget Sound across Tacoma. Go back a day before that to the 9th. Look at this. 8. Northwest Oregon only. So we went from 8 up to 82 up to 112. So it's slightly increasing. I wouldn't call this a ETS big slow slip or anything. It's little pockets or asperities that are moving or shifting. The plate is shifting slightly. And now here we are, as of yesterday, shifting in Northern California with 100 of them. Why does that matter? Getting back to the earthquakes. Northern California, we dried out up here. It's now no earthquake activity at all coming out of Northern California, going down into the north tip of the valley, which shifted yesterday. Now, it shifted yesterday, and then what happened? A 5 struck downstream, following the direction we expect our arrows to take the energy out across over to the edge of the craton. So it shifted yesterday, Northern California, followed by a 5 down at the volcanoes. Everything up to the north has pretty much gone quiet. Yellowstone's swarm died out. The swarm over in central Idaho died out. Like I said, no earthquakes reported across Oregon. That's tricky. I don't know if that's real or not, or if they're just not reporting the earthquakes. But certainly the earthquakes up in Washington seem to have slowed down. The tremors in Washington have pretty much stopped. We get down all the way into northern California, south of where the plate shifted, south of where those little red dots were that I just showed you on the tremor map, and we pick up with the number of earthquakes. Again, big earthquake, 5.0. Past couple days, it's really been swarming. Now we get to geysers. That's the volcanic feature here, right along the San Andreas. And we have one earthquake in the Bay Area, 2 earthquakes on the creeping section of the San Andreas, 2 earthquakes down at the south tip of the valley at the Garlock. Ridgecrest has also died out. So Ridgecrest, Cozo Volcanic Field. The number of earthquakes here is, you can probably count them on one hand, or 2 hands. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 2 hands and a foot. We're talking like 15 earthquakes. That's low. So it's low at Ridgecrest. It's low on the creeping section of the San Andreas. The number of earthquakes down in Southern California also dropped off. It was huge. We had stacks of earthquakes, big stacks. Now it's next to nothing. So the flow has been cut off, or at least it's died down. And I would say whenever we see the flow get cut off, we watch for a new increase to take place. Now I'll wait. Hold on. 2 new earthquakes just struck as I'm talking. Oh my God. One up here right north of the Bay Area, right next to geysers, 3.3 just struck. And a 1.1 just struck down on the creeping section of the San Andreas, the spot I was just zooming in on. So a new 3 has come rolling in right now. 3.3 up to the north. Right next to the plate boundary. Let me show it to you on the plate boundary map. This is where the red earthquake is, just hit. So up here, when did this strike? UTC, let's see. 3.3 struck at 1920 UTC. 4 minutes ago, the 3.3 struck. So now, this one just struck at 1921. 3 minutes ago, the 1.1 struck. 3.3, 1.1. California shifts ever so slightly. It's moving more over at the border, obviously, with the 5.0. That push when the plate shifted came down. Should go over. We should see an increase over in Oklahoma, Colorado, Texas, and the New Madrid seismic zone. Number of earthquake-wise. Magnitudes, too, should also go up, 4.0. Should see 4s coming into Oklahoma, 3s going down across the edge of the craton down into Texas, and a swarm going up to near 3.0, likely, on the New Madrid seismic zone. That should all happen in the next day or two. I mean, the 4.9 hit last night, right at the back tip of the arrow. So, I mean, come on, checks in the mail, it's coming our way. Down to the south, where it goes quiet, and I don't see any earthquake activity down in Southern California, but just a handful across the Anza Gap. The cluster is down at the Salton Sea Geothermal Electrical Generating Stations. It's gone quiet, guys. So quiet means new push coming in. A 3 coming in is not that big, at least as far as I can see. That's famous last words, right? I would look between our current sets of earthquakes. How many points is that? Okay, let's start to the south. Find our middle points. Middle point here between our sets of earthquakes at Ridgecrest and our sets of earthquakes down in the south point of California, south tip of California, going across Westmoreland and stuff down to the south. And stuff. Oh, that's real good. That's real good. That's real professional there. Yeah, it's good to stand and stuff. Yeah, you know what I'm saying. Hey, well, you know, we're doing this live. Sometimes it just slips out. My casual nature just comes out. It's okay. It's all the way down to the east and stuff, you know. That's funny. Okay. So a line of earthquakes going down to the volcanoes and geothermal pumping operations down in Southern California. The middle point is the LA Basin between the two. So I'd look on the creeping section, south of the creeping section of the San Andreas. I guess that's just the San Andreas, north of LA. How big? Something bigger than what's on all sides right now. So what are we dealing with to the north? 4.9? So it should be in the 5 range. Time frame on this should be the next 4 to 5 days. Not even. Next 3 to 4 days. So that puts us by the 15th into the 16th. So north of LA, it should be on the fault out here near the Mojave, I think. So, you might, if I'm right about that. If I'm wrong, something else will happen, obviously. That's funny, too. I'm cracking jokes now. So if I'm wrong, something else is going to happen. If I'm right, it's going to hit right in the middle of the area, and it should be a 5 up here out by the desert. Where else? Okay, so Ridgecrest has gone down in the number of earthquakes, and this is the weirdest thing because a study just came out from IRIS, I-R-I-S, the seismic agency that provides data to the USGS, talking about how Kozo Volcanic Field is somehow excited when earthquakes strike around the rest of the planet. Let me show you where Kozo is next to Ridgecrest. They even bring up Ridgecrest in their study. But here's Kozo Field. Now, I'm here to tell you, it's not just Kozo Field that lights up after a big earthquake overseas. It's all of our geothermal pumping operations and the volcanoes going up across the whole coast of the United States, up into Canada. See, it has to do with the red line, the plate boundary here, and the vibrations that come across the plates, and focus in on the weak points in the plate. And the weak points are volcanoes, oil pumping operations, geothermal pumping operations, and volcanoes. And that takes me back to the start of the update. A big push. Oh, look, another earthquake just struck down in Southern California. I'm talking about Southern California. That's a 1 in a million chance for each location, and to have that many, it's just too weird. Let's go over to Texas really quick. Pumping operations in Texas, oil and gas, at the edge of the Craton in Texas, by the way. This is 24 hours worth of earthquakes. Oil pumping operations and gas pumping operations across Oklahoma, all at the same level, 2.1, 2.1, 2.0 across Oklahoma, and the bigger of the bunch, back at the pumping ops over in Texas. One lone earthquake on the New Madrid seismic zone, right in the middle of it. And then a lone earthquake over to the east as well, on the edge of the Craton in South Carolina. Let's go look that one up, see what the deal is. It's a shallow earthquake, Columbia, South Carolina, right in the middle of it all. Let's go see what's there. We're talking rare. Only when the plate's really moving. And we know it's moving. Maine moved. Okay, here's the earthquake epicenter. Man, we are right in the middle of a residential area, aren't we? What is this? What's all that? God only knows what that is. Okay, do we have anything here right along the road? Looks like some assisted housing, maybe. Some stadiums, if you will. I don't see anything else. I'm not seeing any kind of huge power station here. Am I missing it? Oh, we have 2 huge quarries right next to it. Wow, those are deep. We have 2 deep pit mine quarries right next to it. And it's a shallow earthquake. It's up at 0.7 kilometer depth. Maybe I'm missing it. Let's just zoom in around the area right here and see if there's anything else nearby. Oh, no, wait. There's one right here. There's a quarry right there. That's weird. That's a weird place to have the quarry. Right in the middle of the city. All right, well, we're right next to a quarry. I would put it, if it's at the surface, it's next to a quarry, unless we have some kind of other feature here nearby, some kind of nuclear power plant or power generating station that's just massive that would dwarf the area. I would lean towards the quarries as being perforation points in the crust. In other words, like a scoring on a piece of stone. You guys know how to score a piece of stone to break it? But it's scoring on the edge of the Craton. And then forces applied across the Craton. Oh, wait, we got a hot spot that's here. Hold on. In North Carolina, just north of here, we have a hot spot. What is going on here? A hot spot? Is there anything? Oh, wow, look. The power lines again. The power lines again. The big kind, not the kind that go to your house. The high voltage transmission lines. Right next to it. Here's a bunch from yesterday. All these from yesterday, amazing. Oh, wait. Something's going on down along the coast of Louisiana. Look at all the hot spots along the coast of Louisiana. What is down here? The bayou itself. Look, these are waterways, guys. This is all water. You can't even drive a... You might be able to drive a car down some of the roads here. Yeah, here's a road. But you can see the waterways. This is the swamp. Ah, I get it. Must be swamp gas. Here, right along the waterway. All over the place. The whole coast. All lit up. Let's go see what's going on down there. We got to go look at that. Something's going on down there. Those aren't fires, guys. There's something else going on down there. Edge of the Craton to the south? Down in Louisiana? What? Oh, look, there's... What? It's like raining there. Shortwave infrared. Maybe that'll show it. 200 images. You can't even see it. What the heck is going on down there? Let's go look at the radar. Maybe the radar will show us something. Radar selections down in Louisiana. Oh, wow. Hold on. They got something going. Something's going on down there. They got rain. It's rain to top it all off, guys. It's raining down there. That's actual. Look at the storm going through there. Look at that. Big rain, too. Not just a little bit. It already passed through. Big rain already passed through the area. It's out in the ocean now over to the east in Mississippi. But yet, we're getting huge outbreaks of hotspots. How hot? 64,000 again. And the computer doesn't even know what to do with these. I'm wondering if another radar station is bombarding this location, not from the... Where is this one from? Okay, this is New Orleans. Let's go look at the other location over to the west. Of course, this one's off. It got destroyed in the hurricane. Completely wiped out. Let's go up here to the north. That's right where the storm came across. Something's going on down there, that's for sure. So you don't get that kind of widespread heat signature. Look, down in Texas, too, there's a line going through here. What's going on through there? Got another waterway through there. That's odd. These power lines, too? That's a pipeline. So this is following a path of a pipeline. Is this the railroad too? No, that's just a regular road. That's following the path of a pipeline. We're also... Oh, look what else we have here. A huge... Look at this. Some kind of refinery. Oh, look, they got their own power generation going on there. Massive power generation. Look at that. That's huge. What are these? More refinery with more huge power generation, too. So refinery, I guess they have their own power generating there. Is this where all the power lines are going to and from? Yes, sure is. Look at this. Glad I checked. Gotta check these guys. We gotta look at each one. I mean, you cannot tell me that right there is farmers burning their field in the middle of a marsh all at once across half the state. And then, look at this. A spread of new red hotspots, equally spaced, all the way up into South Carolina. Or Georgia. Where do we start? Is this Wright Air Force Base? Eglin Air Force Base. Oh my God. We're starting at Eglin Air Force Base. These are the radomes. Isn't that what those are? Pretty sure that's what those are. No, wait, are those the laws? Are those laser weapon systems? Oh, it's part of the military, that's for sure. We're on the military range. Okay, that's where we start. Oh my God. We go over here. Here's yesterday's. We go over here. Here's the current ones. Oh, look what we're right next to. First of all, series of high voltage power lines. Secondly, I think that's also too part of a U.S. military range. I don't know. Let's go see. What do we have here? Clear cuts. Nice houses. Ah, that's where the general lives, right? Okay, let's carry on over to the east. Oh, we're right next to the NEXRAD radar, north of Tallahassee. And do we have anything else? Right next to the Tallahassee NEXRAD. Oh boy, it's in a marsh. Look at it. You see that? It's a marsh. All right, you can see where they ride those boats through the marsh. You see that? Somebody will take a boat through a marsh and spin it around. So, hotspot in the middle of a marsh, next to the NEXRAD radar. There's got to be something else there that I'm just missing. It quite literally is a marsh on all sides. There's a house out there on the back side of it. Imagine living there. Or like lily pads on the surface. That's what those are. The heck? You see that? What is that? Okay, enough of that. Let's move on. We're going up into Georgia now. See, I don't want to spend too much more time doing this. I think I proved my case that we're along mostly power lines. Some railroad tracks. All right, that gets me back to the earthquakes, and that's a good end to this. The earthquakes striking next to the hot spots, or very close to them. Hot spots spreading out across the plate, same time the earthquakes start spreading out across the plate. And then where are they coming from, the hot spots? Well, if they're coming from a lot of the power lines, which they appear to be, and pipelines, the long stretches of metal, pipelines, power lines, oh, and railroad tracks, that they're somehow catching an electrical charge, maybe. Something else, some kind of electricity coming up out of the crust. That could be also possible. Do you guys have an earthquake plan? Do you know what to do when an earthquake strikes? That's where I always end my updates, but let me just tell you, you should just take shelter. It's pretty basic. I've never been in an earthquake of any size, knock on wood. So I really wouldn't know what to tell you to do. Don't panic. I would pre-pick out an area that I would go to and try to get there. So table or a desk. And if you're not confident in your structure, you would need to have a place outside to go. That means you need to pre-designate an area outside and scope it out beforehand to make sure there's not anything there that can harm you. Make sure the people in your family or your household or, well, even at work, that you have an area pre-designated to go to and that you know to meet up outside if you have to go outside. Regardless, though, you should take shelter first. And that's, again, where the taking shelter underneath a table or a desk thing comes in. You need to have an emergency kit. And I'm not talking about the kind you buy. I'm talking about the one you put together yourself. Like a bag with a change of clothes and a set of shoes, food and water for a couple days. You're not talking about the long-term survival gear. I'm just talking about an emergency kit that you could grab, and if you're going to go outside for a little while, you might not be coming back in for a few hours to maybe even a few days. So make sure you have the seasonal specific items that you need. Also, think about first aid, communication, sanitation. Think about kids and the disabled if you have them in your life, or neighbors even. Think about those. And you'll be way better off than all the other people out there who just refuse to prepare. And I think they get lulled into a sense of security because their lives have been somewhat secure and they haven't been told by anybody to prepare. It's just that simple. And once you tell them what to expect, in this case, we're talking about 5s and 6s and potential of large earthquake activity in the West Pacific, going up into the 7 range. Now, forecast-wise, I will issue a new forecast here at some point in the next day or two. Now that we're 2 days in on the solar storm, I think we're pretty much imminently due for large earthquake activity to replace this 5 and 4.0 activity that we're talking about now. I hope I'm wrong, but in the next few days I should be back on reporting about large earthquake activity and a spread of it. We've seen it happen enough in the past, that's why I'm looking for it now. It would be an anomaly, actually, to have a solar storm and not see a large earthquake develop as a result of that. So we'll wait and see. We are 2 days in, and that's go time. If you're watching on Twitch, which is live, thank you very much. Word up, much love. Thank you for all the support you've shown and for the subscribers, which do financially support my operation. And to everybody who's watching this over on YouTube, cheers to you and thank you for sharing the information. It's making a difference. I am 100% certain that the message is being heard by the professionals and by people around the world, thanks to the sharing on YouTube and the people who are subscribing on Twitch. You've done your part. You've got it out to the world. They know now. There is no going back on this. The fulcrum points are getting hit. The deep earthquakes are spreading out and away, leading to larger earthquakes. It's excited by solar. This is an exciting time in geophysics, where old, outdated, outmoded dogmas, beliefs, if you will, are being replaced with actually observed science. And the observable science is defeating and debunking the previously held beliefs or dogmas about earthquake activity in particular. Like, for instance, they used to say that earthquakes were random. And they still try to say that earthquakes are random. But we know they're not. They're following the plate boundaries and the craton edges down to specific regions with specific magnitudes. We can see it spread across the North American craton. We don't need a person to tell us that it's not possible. We can see it that it's happening. So they need to adjust what they said previously. They said there was no progression of earthquakes that happen across plates. Why would they say that? Well, they had never observed that it was happening, apparently, so that led them to make statements to say that it doesn't? To me, that's odd, that there would be declaratory statements made that something's not happening when they've never set out to prove that it's not happening. I'd like to see the proof that it's not happening. Why do they make those statements ahead of time? Well, this gets into a whole different section of science, which is the theoretical sciences, which they like to dominate into the physical observable sciences. And we see that happen over and over again, where people who are theoretically denying something are denying something that's visible right before their eyes. Telescope, for instance, and Galileo, a good example. You have a scope, you can look through it, see something far away, case closed. Well, the theoretical people wouldn't look through the scope. They accused him of such and such and did everything they could to stop it, because they had previously said there were no other planets like that out there. Or if there were, you couldn't see them. Or if you could see them, that they weren't planets, that they were gods or whatever. And that conflicted with what people had dogmatically believed up until that point. So in this day and age, the dogmatic belief is that earthquakes were random and that there's no relation and that earthquakes can't be forecast just because some egghead a long time ago said it. Ask them to prove it. They say to you, no, we can't prove a negative. It's up to you to prove earthquakes can be forecast. So I published the method, how to forecast an earthquake, and what did they do? Iris responded and said they didn't want to test the method. And they said that publicly, and we all laughed at them and walked away and said, okay, you lose. I said, is that your final answer? That was actually my response. I said, is that your final answer on Twitter back to Iris? And that's it. They sealed their fate. So we're doing science without them, and that's fine. The agencies never really were known for doing science. They were always known for following up and taking what was somebody else's discovery and packaging it and putting it into a book to cash in on it. All right, guys, I'm out of here. I'm dropping bombs. Time to go. Peace out.